Hello everyone, welcome back to another video. Today I'm going to be doing some math here. I'm using algebra and patterns at the same time. Some people might find these questions tricky, so I thought I'd make a tutorial on it, and let's start the problems. So for the first problem, I have a hashtag. It's weird because you might not usually see a hashtag. B equals a squared plus b. And we have this expression right here. And now the problem wants us to, what's the value of 2 hashtag 1, right? And that's in parentheses. So it's like this. We have another hashtag. And then we have 2 hashtag 1. So we don't know what this hashtag is. This is very weird. Nobody, of course, knows what this is. So what we're going to do here is we're going to try to figure out what this hashtag is and solve this expression right here. So, of course, if we're using PEMDAS right here, order of operations, parentheses, exponents, so it can be like that, multiplication, division, addition, subtraction. There we go. So we have PEMDAS and we have parentheses here. Now we know a hashtag b equals a squared plus b. Now if I take a look at a and the hashtag, a squared wouldn't, like, a hashtag b equals to a squared plus b. So if we think that 2 is a, if we think about this, and if 1 is b, right? So wouldn't this be 2 squared plus 1, right? We don't know what the hashtag is yet. We'll come to this. But of course, let's get the exponents, the parentheses, out of the way. We know what this is, right? So let's solve this. 2 squared, of course, is 4 plus 1. And then we have our hashtag 4 plus 1. Of course, that's 5. So once I'm done with this, I can go right here. And yes. So once we're done with this, do 5, hashtag 5. So we don't know what this hashtag is, of course. Well, a hashtag b is equal to a squared plus 1, right? So if this is a, 5 is a, and this is b, wouldn't this be equal to 5 squared plus 5? Am I right? This would probably be equal to 5 squared plus 5. So 5 squared, as we know, is 25 plus 5, 30. Here we are. That's 30. The answer to this is 30. You can see I'm going to write it bigger over here. All this handwriting. And yeah, so we came to our answer 30, wrote it down, figured out what this is, and then solved it. Sometimes these problems aren't as hard as they might seem, but you have to make sure always to plug these in. So we have a different one. It's 221 squared minus 220 squared. Now, some people might just go straight ahead and some people might go ahead and straight straight up do that. However, if we take a look at this, you don't have to. Some people might just start doing this. This is a very long problem. It's going to take you a while. And with all this calculations, you might make a little mistake, which will cost you the answer. And same with this one. 220 isn't that much smaller. It's literally the same thing. So, this is not what you want to do. Instead, there are many better options to solving this problem. So what we could do is, well, let's take a smaller problem like 4 squared minus 2 squared. And let's think of this as a square. Let's draw a picture. Now, this is not to scale, but this is just a square. 4 squared is, of course, 4 times 4. Times 4. So we can do 4 over here, 4 over here. That's 4 squared. But we have to think of 2 squared as a smaller square inside of 4 squared. So that square could be like this. This could be 2 squared as well. So our goal is now to find the area of this right here, rectangle. You can see here, and subtract it from this smaller rectangle. So basically what we're doing here is, if I can do this, there we are. So the first step is, of course, let's find the area of this. This entire length of this side is 4 units. This much is 2, and this is 4, so 2 times 2 is 4, so we know this is going to be 2. So that is 2, and that's 4. So this much is 2. Be precise, that's 2. 4 is the entire length. So that's the entire length, that's only 2. This is 8, right? This one is again 2 over here. Down here, it's of course 2 as the length. As you can see, we already have a 2 right here. But we need the length of the bottom one. Now, using this method, we can derive a formula to solve a problem like this. Now, of course, this is going to take me longer than if I just do 4 squared is 16, 2 squared is 4. Here's my answer, 12. Of course, this method is not ideal for small problems like this. However, if we want to take a look at let's say a harder problem, such as this one, you're not going to be able to solve it. So this is why we have this formula. Using that square method, we can derive a formula, and that formula will be A plus B times A minus B. Now this is basically saying, like, the area of this square times the other square minus that. So basically, if we just plug in this formula right here, 221 plus 220, if we assume that let 221 be A and 220 be B, we can add this 1, 4, 4, 441, and now we have A minus B, which 221 minus 220 is 1. So 441 times 1 is 441. So as you can see, this was very easy for a huge problem like that. I used the I visualized the actual square, like the meaning. Like if we take a look at 221 squared, doesn't look like a square. However, if we take it 221 squared, it's a square. Right here. And of course, 220 squared is a smaller square somewhere inside. Of course, this is not to scale, but 220 squared is obviously 220. So of course, let's think of it as a smaller square inside the bigger one. And that is how I derived that formula. So those are my two problems. First one is kind of related to algebra. One of the trick questions. This one, I used the faster arithmetic methods to solve the problem. So yes, that is how you solve these two problems.